Hello, everyone. It's time once again for Catalog and Cocktails, your honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd product guy, joined by Juan Cicada. Hey, Juan.
Hey, Tim, how are you doing? It is always a pleasure to be in folks' ears. And maybe if you're watching this too, take a break in your day and come chat about data. And today, super excited, very special connection with our guest today. So our guest is Alex Bertails, who's a software engineer in content engineering at Netflix. A couple of months ago, they announced this unified data architecture. There's been a blog post which really went around just all the LinkedIn's and all the internets of the world right here. People reading about this. But Alex and I worked on a W3C standard together. We're both editors of the W3C relational database RDF standard on direct mapping. And we worked together probably 15 years ago, and we would talk every day for a couple of years, but we've actually never met.
That's true.
And we haven't actually talked in a long time, and probably over a decade. So, anyways, Alex, it is such a pleasure and honor to sit down and chat with you today here. How are you doing?
I'm doing well. Thanks for having me.
Well, thanks for accepting the invite. It was really exciting when that whole blog came out and you pinged me about it, and we're like, yes, this is so cool. We're going to dive into that. But before we do, what are we drinking and what are we toasted for today? And if you're not drinking what you're supposed to be drinking, what is your favorite cocktail right now? But
Yeah, so I'm actually at the office right now in Los Gatos, and there is no beer or anything alcoholic around. So I really like the bubbly stuff. So yeah, that's what I'm drinking right now.
and if what is your favorite go-to?
Yeah, what's
beer,
your
wine,
cocktail or drink of the moment?
Yeah, since I've moved to California, I like anything, like tequila, that kind of stuff, which is not something that I was getting into when I was in France. Like we don't really see that much over there.
Yeah, tequila. I think I'm more of a mezcal person, but actually I was in tequila like a month ago and had some interesting tastings. And there's a lot to
Mhm.
really enjoy about tequila for sure. And then
Yeah.
how can you not like just a good margarita? There are very shitty margaritas, that's for sure. Be very careful about that stuff.
Yeah.
But
Make a nice
Yeah.
margarita.
yeah, very nice margarita to that. But how about you, Tim?
I'm actually going to give a shout out. So usually I'm like, hey, what my favorite cocktail of the moment is. I'm going to give a shout out to some syrups.
Okay.
There's a company called Liber that makes really, really good syrups. So if you want like a pre-made, a gum syrup or a raspberry syrup or something like that, it makes some really good cocktails. Also, Portland syrups are really good. So I've been experimenting with both of those right now.
You know what? I never thought about syrups. Okay,
It's kind of a pain in the ass to like you get the pot out and you can make your own syrups, but like you buy the syrups.
All right, let's kick it off. Honest, no BS. What is Netflix unified data architecture? What does it actually mean to model once and represent everywhere?
Oh, that's a big question. It depends on where you're starting from. I like to start with the problem that we had to solve. So when I joined the team like a couple of years ago, we are still dealing with a lot of data models everywhere. So we're part of a enterprise kind of part of Netflix. We have data models that happen to be in a lot of GraphQL services, in a lot of iceberg tables, or in transit in data mesh architecture. And it's really, really hard for everyone to reason about all of those data models. So there's a lot of duplications within systems, like for the same kind of entities, but even more so in between systems. So it's really hard to reason about that. And what we're really missing is that one schema to really rule them all. And that's how UDA really started. It wasn't called like that at the very beginning, but if we have to describe what it is today, it's really a knowledge graph with three main components. So you have the domain models. We are not saying ontologies, we are calling them domain models. We have the mappings and the data containers, and we are really connecting everything into that knowledge graph. And before I get the question, what do we mean by knowledge graph? We really mean RDF, and even more so conceptual RDF. So that's what really is unifying everything under the hood. Yeah, so that's really the short answer, but I'm sure we're going to get more into the details.
Let's to get very specific. You said three things: domain models, mappings, and your third one was the containers.
Data containers, yes. So
expand on that. What do you mean specifically by data containers to get our terminology straight here?
Yeah, so for us today, we know, for example, like this is an iceberg table. Here's the location, here's the schema. We have a data mesh source. Here's the arrow schema, and here are the coordinates in data mesh. And or this is a GraphQL type, and we have the exact coordinate, for example, of the type resolver in the enterprise gateway to really interact with the entities. So all of that for us is a data container, anything that can really contain information, data, and we can actually ask more information about that we can interact with the data through the data containers.
You know what? So I've actually been thinking about this as these three layers. I think we're aligned on. I call it the technical metadata, your business metadata, and then your mapping metadata, just connecting the stuff. So like if you think about these containers, it's technical metadata. Like this is stuff that's out there. I mean, if you're coming in from let's call it a legacy world, right? Like this stuff is out there. Let's go catalog it, all that technical metadata. It is what it is. The business metadata is where you want to start modeling things out, right? Yes, they're ontologies, but this is kind of your domain models, and you want to be able to connect these stuff. What does it mean? And then these level of connections can be very high level. Oh, this thing is related to that, but I can get much more specific around that. That's my rephrasing and my terminology. Does this align with what you're kind of doing here too?
That is correct. But in our design, there's actually something very important. We do not make any distinction between data and metadata. Everything lives in the same world. And that's actually a key, it's a key part of the design in what we have.
You're blowing my mind.
So
what does that mean?
Yeah, expand on that. What is something that people would consider different than you're saying here is the same?
Yeah.
Can you get an example?
Yeah. So what I like is actually to go back to. So that's funny when we talk about that. I send people back to the RDF specification that was published in 1999, and I tell them just read the first two paragraphs, and that's everything that you need to know. And there's a very important phrase in there which says the distinction between data and metadata is not an absolute one. It really depends on the application, and to us, that's really what RDF is all about, and that's what we are using. So when we say, and we talk about that as conceptual RDF, and what's really important for us is, well, first, for the core of the knowledge graph, we do use actual RDF data, that is data as RDF triples that are materialized, and that's what we interact with. And then you have the conceptual RDF, which is more the abstract conceptual framework in this case that we're using. And that allows us to move in between all of those data representations, whether it's SQL, Avro, GraphQL, or even Java. So in that case, we're connected to more like a virtual RDF graph. But at the end of the day, because we have one way of describing conceptually all of those things, it's still one unified RDF knowledge graph.
All right, I want to jump into applications, and then we'll go back and forth into more detail. So how is this being used? So Magic Wand, right? You have this knowledge graph of all of this, the domain models, right? The mapping to the data containers. You have all this stuff done. I want to get into later, like how is this being built and managed and governed? But before we go there, so what? You have this. How is it being used? What is the value that the organization Netflix is perceiving, getting out of this?
Yeah. So the main two big applications that are actually built on top of UDA as a platform, and that's described in the blog post. But I will start with the one that we call PDM, Primary Data Management, which is really taxonomy management. So the way that it works, and that's pretty big. So think about finance. They go into UDA and they define their taxonomy or domain model for region. So you find things like countries, territories, and like a lot of very advanced stuff. Then they go to the PDM platform, and then they can equip the domain model with taxonomy information. So we use COS for that. and automatically they would get actually a UI that is derived from that. They get so they get a way to automatically manage their reference data for the region taxonomy. And then they go back to UDA and they say, okay, now I have that one domain model and I have some data. Now, please make it happen everywhere all at once. So all of a sudden, we actually provision some GraphQL service that gets federated into the enterprise gateway. So other services can actually leverage that. They get a data mesh source where they can actually write into, and now they exist everywhere in Iceberg and in the data warehouse, but they have nothing to do. And that works the same way for any kind of domain model with its own taxonomy. So that would be one application that is very much in use today. The otherwise it's very different. So it's called Sphere, and we have that as well described in the blog post. And for that one, the idea is I'm a business user. I kind of know, the domain because I'm an expert, but I have no idea where the data is, how it's represented, or whatever. But I should be able to find my concepts if you give me a way to search for them. So I should be able to go to that marketplace and I say, I'm interested in movie, in talent, in production. Please find the data wherever it is, craft the SQL query for me, and generate a operational report for me. So that's what they can do. And the way that it works, again, that system is just leveraging all of the domain model that we have extracted, in that case, from the gateway. It's a real knowledge graph. They traverse the knowledge graph. They know how all of that stuff is mapped into the data warehouse. With all of that information, they know that they can generate a joint query, and that's exactly what they do.
So this is interesting. So zooming out a little bit. So you created these applications and they're creating some very important value. Why were other solutions not viable here? Why was this the approach that you guys decided to take?
And to add to that, what were you doing before?
Yeah. Was there a before and an after?
Yes. So that problem of connecting applications and data across the business is something that we were looking into for a very long time. And I mean, if you look into what people are trying to do today with semantic layers and all of that. So if we talk about semantic layers just for 1 second, most of what you can see out there is people doing that just for the data warehouse. And there is a lot of efforts that are put into that. For us, it's only one part of the problem, like the data warehouse. A big part of the problem is actually happening on the operational side, where you have a lot of microservices trying to integrate with each other. So where Netflix was actually trying to to tackle that problem was more on that side. And there was a big bet that GraphQL would be that unifying layer. Like federated GraphQL is really the bet that was taken 6-7 years ago. And there's nothing out there that is trying to really put all of those worlds together. So, but that's what they were trying to do. I think the hard realization was that GraphQL is not really a good conceptual modeling language, but it's very, very good for federating APIs. So it really got us to where we are today, and but that was not enough. So we were still missing that conceptual layer, and we knew that we needed something else.
Okay, so if I rephrase this in my words, and let's make sure we're aligned. Mm-hmm. There's a world of just analytics, and then there's the operational world, and then when you think about kind of adding that layer of that conceptualization, that layer of semantics in the analytics world, there historically been these semantic layers, these BI semantic layers for that. And then the operational world has kind of kept it it's called very more application centric. And then people are like, yeah, you can model things per application, and then I'll model things for this API. Oh, the GraphQL can do some modeling stuff, but these were all very disconnected. But at the end of the day, the concepts, right, the semantics across the operations and the analytics, they should be the same, or usually they should be connected. So instead of having these separate worlds, you're like, wait, let's go start kind of creating this unified world of the domain model, aka the ontology, right? But it's a domain model, right? Then you want to be able to use that domain to map it to all these different systems that you have. But at the same time, you should be able to go use that to automatically generate any new application code, new schemas, new Java code, whatever, such that nobody has to go rewrite that again. I mean, that has been defined once. Just go reuse that all the time. And so the opportunity here is to really unify analytics and operations, and at the same time, just again, define it once, and then not have people go do it over and over again, and then actually get it wrong. That's my summary of here.
That's exactly that. That's exactly that. So I don't know if you've heard about the concept of shift left. Trying to do validation. That was actually popularized by Confluent. That was the idea of trying to do more validation closer to the source. And that's what we are doing exactly for the data model. So we are trying to bring the conversation at the conceptual layer so that we can actually drive more of the automation and the projections and the data representations automatically. But we have to actually move closer to the conceptual layer in order to do that. Otherwise, you don't have enough expressive power. Like, you can't extract enough semantics if you don't have that conceptual layer in the first place. And that's really what's missing. How do we get everybody to talk about data the same way so that it works everywhere, following the same definitions?
All right. Let's get into a little bit of the how, but actually the how, I think we can get in here from a technical perspective, but also kind of that social aspect of, like, how do you get people? Let's talk about the technical side first. So how is this all built and managed and governed too, right? How do you, what is all the technology stack underneath that's making this happen first?
Yeah. So well, we do have a lot of RDF in the middle of that. But less and less, and it's become so opinionated that we have only the bare minimum that is RDF, and then we have that upper domain modeling language, which is in the middle of everything. And that's really what makes it work. Like, we have we bootstrap everything with upper, and then we derive the entire world from upper. In terms of governance, that's actually very interesting, and I really like when you say the social technical aspect, because for us, governance is a capability. That's how we think about it in the UDA ecosystem. It's not something that is baked in, and that's the same for everyone. So whether you are the governance team thinking in terms of PI over there, or you are the data analyst thinking in terms of the rules to make sure that production and tenant information is correct, that's still a form of governance. So for us, there was a big question: how do we make sure that we have the semantics of upper in place, and governance is something that can come on top of it, just like as an extension. So governance is just yet another domain model, which brings its own constraints and rules, and then we can actually bootstrap everything from there. And in order to get there, so that's really interesting. There is the realization that, okay, in order people go into the system, they want to define their domain model. So first you have to provide a clear definition of what the domain model is. It's not like ontology, you know one when you see one. Well, that's not cut it. That won't cut it. You need actually to be able to say what's not an ontology or what's not a domain model. So there's the definition of domain model itself. And then if you go back to the idea of this one connected RDF graph, if the instance data, the domain models, and everything lives in the same world, they have to be governed by the same kind of mechanism. And very quickly you realize, okay, if domain models can govern instance data, if upper governs domain models, then what governs upper? And so we have this bootstrapping mechanism where upper is actually self-describing. So it's telling you what a domain model is. It's self-referencing, so it's itself implemented as a domain model, and self-governing, so it's able to validate itself. And that's very important because now we can actually focus on upper the domain model. And every time that we define any kind of projection, because it's defined against any domain model, and because upper happens to be a domain model, upper benefits from all of the tooling that we have for any domain model. So in terms of implementation, what that means is, well, because we can generate some GraphQL API from any domain model, we do that for upper. Because we can generate Java code automatically from upper, we do that as well. We can bind the two. And the API, like the web API that is used by the UDA UI, is entirely generated from upper itself. And that's true for a lot of other tools that is working in UDA. So that self-bootstrap thing is actually very, very core to the way that it works. It's not just to be nice, like theoretically it's nice to have that. No, there are very practical, deep consequences by having that design in place from the very beginning.
Okay, so here, what's going through my mind right now is this makes so much sense to me because this is what I've been always talking about for 15, 20 years, right? Same thing as you, but I think why don't we see more of this? And like, why just now?
Yeah, why is this so unusual
because
Mhm.
when you speak to folks who have been in the semantic web space for a long time, right, who has this background, like this is like what you're talking about. It's self-describing, it's self-governing, all these things. Like this makes so much sense, but you also said to yourself, like it seems very theoretical, and I think that's why you don't see this as much in practice. And what I'm personally really excited is when this came out, is hopefully people realize like this is a gigantic, huge example. Netflix doing this. Hopefully more people. This is something that we should be taking more advantage, because there's other things that the Netflix, the Googles, and all the Amazons of the world have done. I'm like, yeah, but you're not a big done. Like you're not going to need that. But this is, because I think this is something that is more about the knowledge, right? The concepts of organization that you really want to be able to kind of treat that as a first-class citizen. I mean, that's it. Like you've really treated knowledge as a first-class citizen, and that's something that everybody should be doing. But what? I mean, anyways, I'm ranting right now. But let me.
Well, that's super interesting. Where do I start? Why? Well, I can tell you what happened. Until 1 year ago, I would say maybe a little bit over a year ago, that we were facing two major problems with that project. One is every time that at the time we were still talking about ontologies, which is true, like domain model ontology. Yeah, I don't have to convince any of you that it's kind of the same thing. But the perception with ontology is that people feel very, very dumb when you talk about that. They feel very intimidated. They feel like they should understand already what it is. As soon as they Google what an ontology is, they find either a lot of documentation that is very technical. They don't understand what that is, or they get into the philosophical stuff and I don't think it applies to them. So there is definitely a perception thing that was happening. So for us, once we realized that, like we were getting some feedback that nobody could understand what we were doing. And we went back to the drawing board and asking ourselves, what are we actually doing here? It took us a couple of weeks, and we decided to rebrand everything in terms of domain model. It was truly a search and replace in the code base and the documentation, but overnight, people understood, like people have an intuition around what is the domain and what is the model. You put them together, they already know what you're talking about. I think that's one aspect. The other aspect is people didn't think it was possible. Like you can work at the conceptual level and achieving semantic interoperability is something that we can derive from conceptual modeling. Nobody has really done it, and specifically nobody has done it for major technologies like GraphQL and Avro and SQL and Java all at the same time. So there was I think that was a big investment that nobody has been able to really done until now. And I don't think people have enough background in putting all of that together in one consistent system and have enough energy to make it happen. And that explains why you don't see that many applications of those principles yet. But yeah, we knew that it was possible, and that's what we are talking. Like we want more people to come with us on that journey. We think it's great. We think more people should benefit from that, and there's nothing specific to us for what we are doing.
So how do you think about how people get involved in this? So you talked about the taxonomy piece, and that's where people have to help. How do you see stewardship and governance kind of folding into the unified data architecture that you all have?
Yeah. So there are different ways. So for us, at the end of the day, right, everything is domain model in the middle. But we actually don't really care that much what it means to bring a domain model. So we have a few ways for people to author their domain models. The main one would be using just RDF total. Doesn't have a great UX, and we do rely on Shackle for the validation and the semantics aspect. That's very bad. But it works. Like we've seen actually over the past few months that once people see the value and they are motivated enough, they make it work. So still with that Shackle kind of validation in the middle. So we have very bare tooling in order to enable that. And that's actually what's being used by the PDM system, the taxonomy system in this case.
Like they're actually writing Shackle, or are they using some kind of a way to generate
using
Shackle?
Upper. So they're using Upper, and then from Upper, we can actually project to Shackle shapes in order to make sure that everything is fine.
Mm-hmm.
Yeah, and it's a lot easier. Yeah, that was another thing as well, back to what Juan was saying about how do we get people to write that. Well, one thing that we learned as well is having too many ontologies. Like asking people to learn a little bit of RDF, a little bit of RDFS, a lot of Shackle, a little bit of OWL, and understanding the data types in XSD. That was way too much for people. So having this additional layer that we control, all expressed in the upper domain, that really made a lot easier. Like we could actually make decisions around how to name things, what are the main concepts that can resonate with people. We talk about attributes and relationships. We don't talk about property relationship or property object or something like that. Nobody understands that. But at the end of the day, that's what you have to manipulate. So yeah, one aspect, model first, using RDF total. That's something that is working. The other one is really, well, we want to leverage and we want to reward everybody who's been involved in the GraphQL ecosystem. So we have hundreds and hundreds of federated schemas. And with enough heuristics, the good thing is that people at Netflix have been using a lot of conventions. So we can actually extract a lot of information automatically for them. And we are able to find very important entities. So we can surface that in UDA. That's still a work in progress. But very, very quickly, that will become by far where most of the domain models are coming from. But that's very important for us because as soon as you are in UDA, you benefit from all of the capabilities that we've been talking about so far. So that will unlock a lot of power for the platform. And then we have a few other initiatives. For example, Java is the language of choice on the enterprise side. And there was a clear desire for people to be able to author their domain models in pure Java. So we have like a bunch of, essentially we have embedded upper in Java annotations plus POJOs, and that people by using that and a few plugins can actually author their domain models, and they participate in UD as well like that.
So, yeah. Let's get more specific on what is upper, because can you give some examples of how upper is defined? Like because you're saying like, well, you talk about classes and object properties and data type properties, right? From an owl ontology perspective here, but upper is, I mean, another meta model around it, which I guess even the way how you're defining things are a little bit less technical. But actually, can you give us very specific examples of, if you can go through an example of what is an upper and how it's defined, and kind of a use case of how you would get from upper down to a domain model and how that's connected to generate whatever GraphQL scheme and so forth.
Yeah, totally. So the example that we use a lot. Have you heard about One Piece? The world of One Piece. So it's one of the best creative work in my opinion.
Talking about the anime series, right?
Yes. Mm-hmm. So it's a world of pirates. So you have a lot of characters, and some of those characters eat some devil fruits, and the devil fruits can give them some powers. So I go into UDA and I can define the One Piece domain model. It's as simple as just choosing a string, One Piece, that is not taken yet. Boom, I exist in UDA. That's enough for me to claim a domain. And then domain modeling, conceptual modeling is happening within that. And upper tells you what are all of the concepts that you can actually bring into your domain. And that's really that. So unlike in R or whatever, there is no concept that exists. In upper, there is a concept that exists. And within that, you are actually limiting what you can talk about. So the main thing that you want to be able to talk about is, let's say, if you want to describe the class of characters in One Piece, you would go for the key derived class, which is really the main concept type in upper, because it gives you a way to exist very, very easily and very concretely in all of those data representations, because you can introduce attributes, you can introduce relationships, and you can introduce a key. So you can define all of the entities with respect to some attributes, and that defines really the class of characters. So you would start with saying One Piece character is a upper derived class. It has the following attributes, like a name, for example. And then it has a primary key, which is made out of that name. And then over there, you would say devil fruit is also a key derived class. And there is a relationship between the two. And I want to call it devil fruit. It's optional. So there's always this notion of cardinality. And then you can introduce an enumeration. That's another kind of concept that you can introduce in upper. So you can say, my devil fruits belong to 3 different kind of types. And here's the enumeration describes that. You connect everything, you register in UDA, and then you can say, please give me the GraphQL, please give me the arrow, please give me one data mesh source where I can write into, and so on and so on. So it is that simple.
And going back to in the governance, for example, people can then easily say, okay, these concepts already exist, so I can go reuse them, or they can easily go off and go create their own thing, and then all of that is then searchable and findable, so people can start understanding what is out there and reuse that immediately to create their own schemas and then connect it to whatever stuff they have.
Yeah, totally. That's very important to know to say. We had to support federation and extensibility from day one. It's very, very hard actually to retrofit federation after you already have a system in place. That's, if you take GraphQL as an example, it was very, very hard for them to retrofit federation. We are still paying the price for that. So for us, we knew that we had to be good at it from the very beginning. Another aspect, I think, very important to understand for Netflix is that we don't believe that centralized governance, having one team that does centralized governance scales. It's both, I would say, a practical requirement and a cultural value at Netflix. So we had to make sure that this was taken care of from the very beginning. So that's why for us, decentralized governance is really the main capability that was baked into the system from the very beginning. So we don't like saying that we are a data catalog, because most data catalog would actually hardcode governance. They would bring their own ownership model, for example. We don't want to say, here's the ownership model. it might actually be okay to have an ownership model for that team over there, but it might actually it might be different from the team over there. And we are not in the business of choosing for them. We're in the business of giving them the capability to define the governance that works for their domain.
How does that approach, that decentralized approach, allow you to still have what is good or what is best surface? How does quality and curation express itself through Upper and UDA?
Yeah, that's the beauty of it. We are not in the business of telling you what to do, but we're going to teach you how to get there. So what we want is to give you the tools to do it. We want to surface that information. We want to make it very concrete to you. As soon as you make a choice, you want to see what it means in terms of all of the projections, like all at once. Here's what it means with respect to everything that exists. But it's not something that we can define for you, and we don't want to be in that position. So capabilities, like we are a platform team. We are not an integration team.
So I'm going to interpret that a little bit, because I think what I hear you saying is that because you're the platform team, you're not trying to dictate that from a governance perspective. Now, a group that's contributing a domain model may choose to, and I bet in many cases are, apply either a looser or a firmer approach to governing their own domain model, right? But it's not the platform's team job. You're providing the substrate by which they can contribute and manage those domain models.
Yes, that is exactly that. I can get into too many details in terms of what kind of governance is, the way that governance is being used today, without getting into more business use cases. But yeah, that's the idea. Like, think about the kind of rules that you would like to see in place if you want to describe production data or movie data. That is a kind of governance that you can express in Upper. I mean, at the end of the day, Upper really gives you the structure to talk about the domain models, but people still have access to the full power of Shackle and Sparkle in order to describe, what are the violations that I would like to see when that's applied to instance data governed by that domain model. So we still resort to that at the end. So there's still a lot of Shackle in order to do that. But really the goal is to become more and more abstract so that we can actually go after more kind of validation independently of the actual data representation.
Yeah.
So what's interesting is that in this episode right now, we are throwing the word, I don't think we've ever thrown the word RDF and owl and shackle like so much before. Like in
Really?
Yeah. What has it been? How's it been at Netflix? Like, I mean, you're talking about this as like, it seems like it's a foundation of what UDA is. So how has been the process of getting people internally onboarded to education around this, the tooling around this? Like, how has that been? And because I'm sure I lived through a lot of like roadblocks around this stuff, right? And I think probably now we're getting a little bit more interest, but like I'm curious to learn more from you. Like, how's it been the process of people accepting this and getting finally, right?
So I only bring up RDF to you because I think you already have an idea, but really for us, it's more like an implementation detail. Like nobody is really, we don't say, hey, this is RDF, this is cool or whatever. That's not at all the way it's happening. If we get into it, we only talk about conceptual RDF, and very, very quickly, what we want actually is for people to see that RDF in the context of their representation of choice. If we are talking to people working again Iceberg, they want to see the SQL schema. If we are talking to someone working on a web UI, they want to see the GraphQL schema. But that's still the same RDF under the hood. So the goal is really to get them as quickly as possible to see something concrete in their world. And then we take care of making sure that it works in the background. And we don't need to tell them everything about how it works.
Yeah, so definitely agree that RDF underneath the hood is just an implementation detail. What is I want to hear it from you. Like, why RDF versus some other technology, even in knowledge graphs, right? People talk about another property graph, another type of stuff you can do. Like, what ended up like doing that? Because for the folks who do care about the implementation details, there what we're seeing a lot is like, oh, why not this thing and that thing and property graph and Cipher and all these things? Like, why not that? Like, just want to hear it from you.
Yeah, that's the most important question, I guess. And it's very easy. For us, every time that we add one small feature in Upper, we have to answer one fundamental question, which is, what does it look like in all the data representations that for which we already have projections? So I give you an example. Like 2 months ago, we added the ability to deprecate concepts in Upper. So you can say that thing over there is deprecated. And what that means is eventually, please do not use it anymore, and that will be removed eventually. So adding that in Upper means we have to go back to all of the projections and we have to decide what does it translate to. So what are the semantics of deprecations through all the projections? Okay, so in Java, we have to make sure that that becomes a at deprecated annotation. In GraphQL, it's kind of the same, but we cannot deprecate types. We can only deprecate the fields. So it means that if someone was deprecating a concept that becomes a type, now I need to push down the deprecation across all of the fields. And then I go to Avro, oh no, there's no concept of deprecation, but we need to make sure that, okay, we have to convey that information. Is it documentation? Is it an extension to Avro? How can we make sure that it exists everywhere? So when you start looking at the world like that, and you have to make sure that you pick the right conceptual framework that will enable that kind of stuff. And property graphs are, for example, already way too advanced and don't have enough semantics to make it easy to reason about that. Very simple subject, predicate, object, plus a few more things that are missing in the RDF world where you can actually reason about the domain. So once you have just enough things with very simple conceptual RDF, you can enable all of that. And it's really, you want that very, very simple model to begin with. And if you stick to it, then you can actually enable all of the other things. But if you pick something that is too difficult to work with, too complex, that complexity would be propagated in all the other representations. And that's very hard to explain. And that makes it very hard as well to go the other way around. Like, let's say that you are starting with the semantic layer just for your data warehouse, and you want to extract that information back into the conceptual layer. And now you have to explain at the conceptual level what is that label property graph. Why do I need so much complexity when all I wanted was really to be able to reason about the classes of entities, their keys, the attributes, and express the relationship to other things. We just don't need more. We want something that is as simple as possible, that does the job and enable all of the semantic interoperability.
This is the realization that I hope more and more people have, because at the end of the day,
me too.
Well, it's because you're thinking about this really holistically with an organization, because you have this balance of what needs to be centralized, what needs to be decentralized. When it goes back to other organizations, like everybody's in their own silo and they're like, well, my stuff works. I don't know. I'm not incentivized to go work with other people. So therefore, having this, what you just said, if I'm going to make a change in the upper, I want this to be propagated all over the place. That's not how a lot of organizations work, even though they should be working that way, but they're not incentivized to work that way. And I think hopefully we are seeing a shift with AI around this. It's fascinating that we haven't even talked about AI yet.
That's one of the questions top of mind for me is maybe we can combine this into one combined final question here is, what's next for Upper and UDA, and what does AI have to do with it, if anything?
AI is an interesting one. Honestly, for us, we are after the knowledge graph and that description, and a lot of the AI conversations have been a distraction from that goal. I'll be very honest. that's my perspective. I know that some of my colleagues will not agree necessarily with that. But yeah, we've been very, very good. We've been very, 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 very good at staying focused on the goal. The prize is that knowledge graph and intent-based data movement. That's really what we are after. So it's not been that much about enabling AI scenarios so far, but I would say we've seen just on small POCs making it easier for people to bring or define their domain models, like agenting workflows are actually pretty good at this point. Like they can understand upper, they can they can interact with the tools like validation tools and stuff like that, and very quickly people can actually get something working. But again, that's more on the authoring side of things. So that's really now that being said, authoring is a big thing that we are starting to pay attention to as we are onboarding more use cases. So far, we've been really focused more on the semantic foundations and the capabilities around projections and data movement. By far, that was really the hardest stuff, the thing that we are not sure we would be able to pull off. So now we're starting to look into authoring. We are very excited with some POCs that we've done lately with more visual authoring experience. We think we can actually handle a lot of stuff like that. That's working well. Discovery is like we have all of the pieces in place, but we haven't really put together that user scenario, that user journey. How do I find stuff? And how do I leverage that stuff? Like I'm looking for a concept and I want to know through all of the mappings, where do they exist? Can you make that available to me automatically? All of that stuff, we know we can do it, but there is a lot of UX questions that are around that. A very, very, very big, interesting subject for us is what we call subgraph composition. So once you have that knowledge graph and you can move data around with a lot of intent, now we can start thinking about big use cases, build on top of that. So things like business rule validation. So we talked about that a little bit more, but doing that in near real time, that's a big problem for us. So how can we do that in real time? Another one as well is, okay, we have that graph, kind of a virtual graph. How can I actually index subgraphs in a very efficient manner, especially in an enterprise setting? Managing indexes is a very big problem for us, and we see that these two problems, business rule validation and graph search indexing, we think it's they are sub problems of something more difficult to solve, which is efficient subgraph composition. So yeah, we are just getting started into that. How can we do that in a stream-based fashion? Can we make sure that we can connect data from distributed sources in real time? Now we are looking into that very actively right now.
And surprise, so these are all fantastic, like really cool things to know what's next. But don't you see all of this knowledge graph? This is the context for agents and more of these LLMs to go use and understand what you want to go. What is the knowledge you have? Is that not one of the things you're focusing on?
Not me right now.
Interesting. It's fascinating to understand the perspective.
Others, yes.
Okay,
I don't think that's really yeah. The
So
knowledge graph
others
is
are
really,
looking at what's being done here and saying like, "Oh my gosh, this could supercharge our AI,"
yeah.
even if that's not necessarily your focus, right?
So yeah, exactly. It could supercharge AI, yes, but before you get there, you need the knowledge graph, and one thing comes before the other.
Yeah, and I think I think it's you said that there's all this internal data movement, all this stuff that is like we've been doing this shit over and over again. Then let's do this right for the first time, and I think you're finally getting that right for the first time.
That's the idea, yes.
Yeah, and that it's somebody who really likes to go to the gym and eat their vegetables.
Yeah, the funny thing is, we didn't have a choice. That's the funny thing. Like we had to solve that problem, and really, it wasn't me. It was someone else who articulated the problem very, very well. There was this internal memo at Netflix called the one schema, and I think that's really what started everything. And that's the thing. Once you have a well-articulated problem statement, very quickly you see that you don't have that many options, but you still need a lot of imagination to put everything together, and you need to have the right team with the right skills in order to really execute on the vision. And it's hard. Like, it took us a while to actually get there. I don't want to make it sound like
No,
it's easy.
appreciate that clarification. It doesn't happen overnight.
Yeah.
Before we go to our lightning round questions to close on this, could you share what is that simple in one sentence? What is that problem statement?
For the one schema?
Yeah.
So it's really, we have data models in different systems, and we do not have one way to reason about them at the conceptual level. That's really what the one schema problem was. How can we do that? It's not GraphQL, it's not Avro, it's not SQL, it's not Java, it's none of them. What is the right way to look at the problem in order to get there? And then we can automatically instantiate all of those concrete schemas, but from that conceptual layer.
Alex, I can go in more and more, and lucky is that we're gonna hang out soon in London for Connected Day London. Not sure if this episode is gonna come out before or after, so we'll see. We'll have a follow up on this, but lightning round question. We got a couple questions already lined up. Very quick, very quick question. So, number one, what kind of companies do you think can benefit the most from the approaches like you applied here for the unified data architecture?
Based on the people who contacted us after the blog post, I don't see the limit. I think everyone will be able to benefit from that. That being said, it's really, as soon as you have a few domains trying to work together and at least 1-2 system, data system to represent information, as soon as you get into that kind of complexity, I think you're getting into the need for a more conceptual layer to really govern all of that.
All right.
Tim. All right. Second question. You mentioned domain models, mappings, and data containers being kind of the three fundamental layers and building blocks of the unified data architecture to enable this model once and represent everywhere approach. Data products are a very hot topic right now in data circles. Are data products a type of data container, or would you say data products and data containers, they're a bit tangential to each other?
So that's funny because we've had a data product solution for a while that predates UDA, and that was our team as well. So all along, we've been thinking in terms of data products. For us, the data product is not just the thing that lands in Iceberg. It's more like the streaming version of it, which is ready to be assembled on the fly. So the answer is yes, it's everywhere in the thinking. And the best approximation of a data product in UDA is what I've been calling in this interview, the key dry class.
The key dry class.
All right, next question. So you took a knowledge graph and RDF approach for UDA. Could you have achieved the similar outcomes with a different way? Or if you would have basically reinvented RDF?
It's a loaded question. Of course, the answer, we would have reinvented RDF. Yeah, another way that so there was actually, so if you allow me to speak on that for 1 minute, after the problem statement was actually established, there was a buy versus build thing that happened internally, and eventually the outcome was we are buying RDF. So we are adopting RDF because it's already out there, and we do not want to invent that. We want to build on top of very solid foundations. And again, that was before I joined, which tells you a lot.
Interesting. So you say we are buying, but we're buying into RDF. That's interesting, right? Okay.
Yeah.
Okay.
Interesting.
Final question.
All right. Final question. What was the biggest surprise that you experienced when you were bringing together UDA?
The biggest one is that we managed to pull it off. I wasn't sure it was really possible to
it's
to
awesome.
do.
I love that.
So
that's honest, no BS right there.
There's a chance you got to the end, you're like, this doesn't work.
So you have to understand there were months of doubts, until Upper was able to validate itself. And then it's really, there is a before and after. Once the shackle validation report comes back empty, saying everything is valid now. But what that means, everything is consistent. And now you have real actual foundations that you can build on top of. And in order to get there, that was crazy. I didn't know if it was really possible. I mean, theoretically, it was possible. But then once we got there, I was like, okay, now everything that the theory is telling us is going to work. Now it's actually real. So yeah, that was the biggest thing. The other big surprise was how important internal marketing is. So for example, not talking about ontologies. And for us, that was one big lesson. Like talking about something that people understand, domain models, terminology, and all of that is crazy important in order to get a platform adopted internally or even externally, I guess. But that was another big surprise. Moving from ontology to domain model really changed everything for us in terms of perception.
All right. So before we go to the takeaways, I want to add one more here on this ontology, because you started a couple of years ago, which I would agree that the word ontology isn't like it was the old word. I mean, it's always been the old word. Don't say it. But I think now we hear it more and more now. And now apparently so many people know ontologies, and like suddenly everybody's a semantic expert on LinkedIn and so forth, right? If you were to do it today, could you use the word ontology?
No, actually, I have one. Now I realized that I have one big beef with ontologies. There is no ontology out there that tells you what's a valid ontology and what's an invalid ontology. So for all of the talks around, from ontology people, please adopt ontology, there is a lack of formalism into saying explicitly what an ontology is. And that's super surprising. And once you see it, you cannot unsee it. And that's real. Like, what is an invalid out ontology? I don't know. What is an invalid shackle ontology? I don't know. What is an invalid upper ontology? I can tell you exactly, and a machine can tell you as well.
Yeah, but well, all right. This is a longer discussion for you and me to have beers.
Yeah.
I think I disagree with you on this one.
Yeah.
But
around
anyways,
big
We
deals.
identified our disagreement
all right,
for
okay.
your further
For
conversation.
okay. We're gonna hang out in London, and we're gonna have a lot of discussions around this stuff.
I can't wait for that one.
I'm looking forward to it so much, man. All right, takeaway time. Tim, take us away, because you need to head to the airport soon.
I do. I gotta leave. So we started off with, how do you make model once and represent everywhere? Like, how do you do that? And at Netflix, Alex, you and your team pioneered the unified data architecture, and in particular Upper, with a knowledge graph approach to manage all of this. And you started by saying it's a big question. Starting at Netflix, there were data models everywhere, lots of different systems where data was being stored. You had a big data products and data mesh initiative, which obviously really took hold in various places. Overall, a lot of information, lots of different places, not a lot of unification around semantics, and a lot of integration patterns going all over the place, right? It makes it very hard to reason about. And you wanted to ask that question, maybe with Lord of the Rings in mind a little bit. What is the one schema to rule them all? And with that question came this unified data architecture. And even though you didn't start off this way, it ended up that what you were building was a knowledge graph, right? And you said there are three main components: domain models, mappings, and data containers that together makes up this architecture. And then, Juan's actually done a lot of writing around this and diagrams and things like this. You've been talking, Juan, about business metadata, mapping metadata, and technical metadata, or the data metadata, right? So it's interesting to see some of the parallels here between these different things. And interestingly, you're not making distinctions between data and metadata. You're thinking of them all being data, essentially, right, that can be leveraged as part of this. And what's the value of the unified data model? You are really driving the value in two main areas with two main applications. One is around taxonomy management with the PDM, primary data management capabilities, and then Sphere, which is more around business users interacting with and contributing to their domain, and then trying to use conceptual needs. And in my mind, I almost thought about use cases, right? Like trying to use the use case and the business value as more the driver on how you want to interact with the right data for what it is that you're trying to do. And why not this versus something else? Most companies are just modeling on top of the data warehouse. So obviously, Netflix has a much more varied data architecture in terms of modality, in terms of streaming versus batch, in motion versus at rest. That's, I think, increasingly becoming true for pretty much all companies now. GraphQL was a great original bet, but it's not good at conceptual modeling. It's good at federating. In general, the conceptual layer was missing, right? And so that's why this came into play. Juan, what about you?
Yeah, so we got a lot into how, and I think upper is this big, I mean, the upper part, which is like, it's the self-describing governance of what is really going to be managing all these different domain models. All these domain models themselves are governed by upper itself, but it's that self-describing and governance. You have, again, a lot of shackle validations, which are just kind of the validations over the shapes of the graph of how everything is done. And that's how you're self-describing and governing these. And you're being able to get a broader set of folks to contribute all these domain models. I mean, you can listen to the part where you're saying how anybody can come in and start contributing to these domain models. Upper, right, lets you flexibly and simply model things like concepts and relationships and attributes to define what are keys and so forth, and making that federation a core concept from the beginning. Like, that was really important. So there's a recognition that central data governance doesn't scale. And I love how I said, I quote, "We're not in the business of telling you what to do." We'll discuss like why no one else is doing this, like why now, and what's made the change. One, it's interesting. You said like, starting off with the term ontology was so overwhelming, and just changing it to domain model actually makes a huge difference right there. And at the end of the day, it was a big investment that really nobody had done, and I think you all took the risk around doing it because you knew it was like the right thing. But can we do it? And you made that investment. You realize you can do it, and you're seeing all this value out of that. We also talked about how, what does it take to get folks kind of accepting all the RDF and semantic web concepts? And he said, well, it's an implementation detail, right? You're not going off and telling everybody that this is RDF around it. I mean, the devil's in the details in there when you need to go know about that. They're focused on the conceptual RDF as you democratize it, but then you have all of these different kind of, at the end, you're trying to say, that's underneath the hood, and you can be able to go get out the particular schemas or the Java code that you need, and that's what people care about. And why RDF? Because at the end of the day, you really want to be able to pick a conceptual framework that enables you to reason about a particular domain. What does AI have to do with this? You're very blunt and direct. AI is often just a distraction. At the end of the day, the prize is helping internal data movement and having this unified semantic understanding and operability. The semantic foundations and projections is what you really were focusing on. Authoring is something that is being focused on next, how to do things visually, discovery, user experiences. And there's a big area of interest around subgraph composition, business rule validations. And at the end, all of this started off because you wanted to get that one schema. The problem statement being, we have so many schemas, we don't have a way to reason over all of these schemas. And that's how this all started. There's a lot more details that we missed here, but how did we do? Anything we missed?
I think that was great. That was great. Yeah, that's pretty much EDA.
All right. Well, to wrap up,
and folks should check out Alex's Medium article. I think it's a really great in-depth approach to this.
And also to remind people, this was years of work. So, and a lot of people.
Yeah.
And to wrap up,
quite a few people. Yeah.
So, what's your advice about data, about life, whatever you want? Second, who should we invite next? And third, what resources do you follow?
My advice would be, don't be afraid to read more on the information science side of things. I think I'm getting a lot from that. I was not trained in that world, but I think a lot of people are afraid by that. So information science, I think, has a lot to teach us. That's what gave us conceptual modeling, for example. In that regard, actually, one person I've been reading lately that I really enjoy, she doesn't know me at all, but Jenna Jordan, she's been writing about data mesh, DBT stuff, and I've really enjoyed that because I feel like she's bringing a lot of that background from information technology, but in a more enterprise setting. So I've really enjoyed that. So she might probably have something interesting to say on this podcast. And what was the last question again?
What resources do you follow? Yeah.
I mean, honestly, mostly podcasts, actually, this one in particular, always been a good one for general information. I do like everything knowledge graph. So knowledge graph insights is a good one. Otherwise, I pay attention to what's going on LinkedIn, I guess. Yeah.
Alex, it has been a pleasure. I'm excited to hang out with you and discuss more about this. I think this is I think one of the breakthroughs that we needed people to have. We needed to see, And I just hope that this is the start of a lot more of people following this.
Agreed.
So
Yeah.
thank you so much.
Thanks, Alex.
Thank you.
Appreciate you coming on. And everyone, check out the Netflix blog article that goes into a little bit more detail. Alex, thank you.
All right. Cheers. We finished the beer.
Cheers.
Thank you.